Yep, still early. Can't get to sleep, so here's the third one. This is Pops on April 28th, the year of our Lord 2024. On the JIK site and antiques, equipment, whatever it was, came up a guy didn't know how to check his generator. He swore up and down it was a 12 volt, but had a cutout relay on it. Interesting thing is voltage doesn't at this point doesn't matter a whole lot. What I'm going to talk about is the operation of the generator. Delco Remy generators, um, on the armature side, is the usual. It's connected to the brush. The brushes go through the commutator and through the armature, out the other side, through the windings. And the interesting thing is the windings are connected to the output. So a little bit goes through the windings, and the resistance is relatively critical. So it's all in-house. So you have an armature terminal, which is the major output from the commutator and brushes, and then you have the field terminal, which in this case is an open end on the fields. The fields run through each other, stationary fields, cross over, go through the other set of windings, then come out to the F terminal. The A terminal is hooked to the armature, the brushes, and the F terminal goes through the fields and back and connects to the outlet as well. It's usually 1 or 2 amps that can flow through that field. That's it. Nothing critical, nothing major. No huge windings in there. In fact, relatively light. Now, to check these things, you can check the resistance in them. 12 volts, if you're only going to run 1 amp through them, is going to be roughly 12 ohms. So there's not a lot of resistance that's going to be there. How do I know that? Volts equals amps times ohms. Just that simple. 12 volts is going to equal 12 ohms times 1 amp, right? 2 amps, 24. That's not what you want. So if you want 2 amps to go through that, then you're going to have 6 ohms, correct? That'll get you 12 volts. Volts equals amps times ohms. So if you want 2 amps to go through a 12 volt circuit, your resistance has to be 6 ohms. Trust me, it is that simple. Let's go back to your generator, Delco Remy system. The field grounds to complete the circuit to run some of that electricity through that. It do. Yes, it do. So, and they're attached together. Now, here's the funny thing. There's some residual magnetism that's in those iron bars that the windings are around. And the idea there is when you fire it up, your regulator, if you have one, has closed. It's nothing to regulate. It's wide open. I mean, it's solid. It wants full juice flow through there. So when you fire it up, a little bit of electricity is created because of the magnets and your armature spinning. It's metal, and the two make just enough to start flowing through juice through the fields. And when they do, it starts coming up and producing electricity in the armature as well, sending it out. When enough is reached, your cutout relay, either in the regulator or separately, cutout relay, will kick in and it'll go to charge. The generator itself is relatively simple. One brush usually is grounded, and the other brush is the hot side. So when it's producing electricity, the ground is ground, like your battery is grounded, so they're all connected together. And the other side is your plus or minus, depending on which ground you have. And if you're 6-volt systems, most of them are positive ground. For electronics and such, they decided to have a negative ground. I don't know what the full purpose of it is, but that's what they decided afterwards. And they made the transition from 6 to 12 volt. It's a rare, very rare circumstances you find any 12 volt system positive ground. Oliver had them. And anything with a generator Oliver had was positive ground, all of them. Anything after that with alternator systems was negative ground. Just something to remember. But on your generators, there's always an armature and a field. On your Delco systems that Case, my Ferguson, and others have, the field is to ground. Now, one guy posted on the VAC case had a cutout relay, and from the field, the wire went and grounded directly. Well, yes, that's because it's not grounded internally as a lot of the old style used to be. So the cutout relay is on there. Now, what's that do? Basically, just what it says. The generator's built for a particular size, puts out only so much to handle a couple of lights and charge the battery. And quite often, there'll be a switch on the other end if there's a cutout relay for high and low charge. The farmer selects it. Normally, it's low charge during the day and running around. You turn the lights on, you go to high charge. And now you put the thing on full bore so it can charge the battery and run the lights because it's only 10 amps, maybe 15. They're very small, most of the old 6 volts in particular, strangely enough. And when it went 12 volts, there were no more amps. It was just a bigger battery, more volts. Strange indeed. So, to test your generators, quite often what I've done in the past is if I'm testing one on the machine, one of the first things I like to do is take the belt off. And I'll hook jumper wires to both the armature and the field. Now, the one end of the field, do not, this is Delco, okay? Field ground. Field to ground, that is. So don't confuse that with the old Autolite systems. So one end is hooked to the field and the other end is left loose. The armature connected, take the belt off and touch it to the battery, the hot side of the battery. If it's negative ground, you're touching the armature to the positive of the battery, and it should. You may have to give it a spin in the direction of rotation of the engine, but it should motor to some extent. Now, some of them won't motor until you ground the field. They'll just kind of sit there. But if you give it a spin, it should take care of itself. If you have to do it in the direction of engine rotation. And other times, I'll disconnect it, put the field down, and attach it again and see what it does, and try and give it a spin if I need to. But once it gets going, usually you'll see it slowly pick up in speed because it's called shunt wound. I've never been taught the difference, but a shunt wound unit has no limit. In other words, if you sit there long enough, the thing will turn 10,000 RPM, if barring friction. Why do I say that? Well, because it's not very strong motoring. It's not designed to be a motor. It's designed to be a generator. It's not designed to take in power. It's designed to create energy. So once you've done this, you've pretty much taken care of polarizing your magnets because they can change positive and negative, and that has happened at times and causes all sorts of headaches. Why? Because it's putting out the wrong juice. When the cutout relay closes, all of a sudden your battery, which is positive ground, negative terminal to the hot side, suddenly your generator is putting out positive energy, and the two just don't go together well. It's pretty ugly. But that's how I generally test it. Now, in another case, what I've done before, here you go, Sid, get your mom, is to test them is fire the unit up and run it. Then actually connect the armature and see what happens. Hook it right straight to the battery with a small light jumper. If you want to put a fuse in there, to be careful. For me, I'm used to it, so I connect it and see what type of spark I've got. And if nothing happens, then I take the field and ground that as well. And quite often, while it's running, it'll take a few seconds to be sure all your connections are there, and then the thing will take off and charge. Always have a voltmeter connected somewhere so you can see the change from battery voltage when you started it, or before you started it, to charging afterwards. And on a generator system, we never used to like to get them over 13.5. 13 is sufficient, not great, but sufficient. 13.5 is ideal. And 14 is, if you're having trouble adjusting it and you hit 14, leave it there. Wait a minute, alternators? Yes, alternator systems are 14, 14.5. And in some cases, I found out with a Kubota and their cheap little dynamo, where it's an AC producer here, and the two wires go back into a regulator to be rectified and regulated. Yeah, they'll go to 15 volts if they're undersized. So your generator, though, that's going to be running in the neighborhood of 13.5 is your ideal. 13.25 to 13.75, that's great. If you hit 14 and it's running okay, then let her run at 14. But they usually start having trouble once they get past up near 14. The battery likes it, but the rest of the system's not always. And it works the generator out. Now, if your battery's very low when you started the thing up, then your voltage goes out the window. I say, what do you mean? Well, if you have a regulator on there, the regulator usually has a cutout relay and a volt amp regulator section in there. The volts and the amps, either one of them can click that thing out. Well, what's it do? It produces 12 volts, 13 and a half, I should say. Let's go for even 14. But if there's a lot of amps going to that battery and that generator's working real hard, it's in the same post, so the amperage can drop the voltage because it's shutting their generator off, vibrating in there on and off to control the amount of juice going to the battery that it's set for. You can change it with a spring on the back, but that's kind of dubious. You're just looking for 13.5, 14 volts. And to test your system, if you got it running and working now and your battery's low, put the battery on a charge. Leave it for a few hours. Come back to it. Yeah, don't use a fast charge. Keep it 10 amps or under. Get it charged up for an hour or two. Then come back and check your voltage on a full battery. And that'll give you your limit of your volts. So that's some idea on it. That'll give you a limit of your volts. And then if the batteries run down or you turn out a lot of accessories on, then you get the other one a rough idea of what your amps are at. So hopefully that helps. If you have one with a cutout relay only, then it's usually a low charging type of generator, and you're going to ground the field permanently. But you don't have to. You can take that cutout relay off and put a regulator on there, but it won't look normal. If that's the case, then I would take the two wires, run them back, and hide a regulator someplace. Then if you need to for people to see it, just put a cutout relay on the top and kind of tape a wire to something. But that's how you can control the RPM. Will control your generator output. That's why when it gets down, your amps fall off. Or if you put a voltmeter on there, they're going to fall off some. So that's just to give you an idea of your generator, your output, and how to test one and run it. Running the engine, after you've polarized it, motorized it, put the belt back on, run the system, and hook the two wires up direct, one to ground and one to, once it's running, the other one to battery. And usually that'll get your generator running and doing quite well. And that'll test you out whether your generator's working or not. And when you know what that's putting out, connect your regulator and run it that way too, and to see what the regulator is doing. They're somewhat adjustable, but you have to be careful. Why? Whatever you adjust it with, disconnect your battery and make minor adjustments only. Yeah, because it can get ugly fast. Hope that helps some of you. Good day.